Alright, so today we're going to be doing our triangle project by Harrison Haber and Davi to solve for the law of cosines and sines and finding the area of a triangle. We're going to solve the following side-side triangle for all the angles in the area.
Okay, first of all, we start using the law of cosines to find the angle A, because it's the largest one. You want to start with the largest one because when you're figuring out the other ones with the law of sines, you have no trouble. Is that a squared equals b squared plus c squared minus 2bc times cosine of a. Keep in mind that all these letters, except for the last one, are for sides. Plug the numbers in, you have 19 squared equals 13 squared plus 15 squared minus 2 times 13 times 15 times cosine of a. 19 squared will give you 361. That equals 13 squared, 169 plus 225 minus 390 cosine of a. Now if you go even further, you get 361 equals 394 minus 390 cosine of a. Now if you get the 394 to the other side as a negative, that is, you get two negatives 394 to both sides, you get that negative 33 equals negative 390 cosine of a. If cosine of a equals x, then inverse cosine of x equals a. So you simply put inverse cosine of the number 0.08461 and stuff, so you can get that a equals 85.15.
After we've solved that angle A equals 85.15, we're going to use the law of sines to find angle B. The law of sines is going to be angle B over the side of B equals the sine of angle A over side A. Now we're going to multiply each side by 13, and that's going to give us the sine of angle B equals the sine of angle A times 13, all divided by 19. When we work that out, it's going to give us the sine of angle B equals 12.95337794 divided by 19. Now we're going to take the inverse sine of that, and we're going to find the inverse sine of 12.95337794 divided by 19 equals the angle B, and their angle B equals 42.98. So, using the law of sines, we could find our angle B after we derived our angle A.
To complete the triangle. If you remember geometry class, you remember that every triangle has its internal angles adding up to 180. So you can say that 180 equals angle A plus B plus C. That is, 180 equals 85.15 plus 42.98 plus C. At 85 plus 42, you get that 180 equals 128.13 plus C. You subtract 128.13 from both sides, and you get that C equals 51.87.
Now that we figure out all of our angles given our sides, we're going to use all of this information to use Heron's formula to find the area of the triangle. So all that together, all your numbers plugged in, our semi-perimeter is going to be 23.5. So the semi-perimeter is all your sides added together divided by 2, so half of your perimeter. And you're going to subtract the semi-perimeter from all of your sides. Then that multiplied out is going to be the area equals the square root of 9,438.875. And then once you calculate that, you're going to find out that the area is 97.15. Our completed triangle looks like this, with all of our angles and sides filled out with an area of 97.15.
You have all the sides and all the angles. You're good to go.